We are now at the dawn of a solar age. Some people call it the age of silicon, since so much of our present technology depends on silicon. The old Stone Age began about 2 million years ago, when chip stones were used as tools. New Stone Age began 8,000 years ago, when the art of pottery was developed and copper was discovered. The Bronze Age began about 1500 BC, and the Iron Age began around 1000 BC. As a matter of fact, all major eras in human evolution are marked by the materials and metals used in social development. For this reason, we might call this era the Age of Silicon, but I like to call it the Solar Age because of the energy issues involved. We take for granted those things that are commonly available. We get upset when it rains, yet we know the importance of clean water. We like to breathe clean air, yet we allow fossil fuel companies to release nitrogen dioxide, carbon monoxide, and sulfur dioxide. Coal ash also has toxic byproducts such as arsenic, beryllium, boron, cadmium, chromium, cobalt, lead, manganese, mercury, molybdenum, selenium, strontium, thallium, and vanadium, along with something known as persistent organic pollutants, POPs for short. These POPs include dioxins and biphenyl chlorides that lodge themselves inside fatty tissues and have half-lives close to 10 years. This is why fatty meats should be avoided. Organisms high on the food chain are particularly vulnerable to POPs. Nuclear energy might seem clean by comparison to the carcinogen waste products generated from the fossil fuel industry, but radioactive waste products are also deadly. They must be buried in special dump sites for many years. Some of those radioactive waste products include strontium-90 with a half-life of 28 years, cesium-137 with a half-life of 30 years, plutonium-239 with a half-life of 24,000 years, cesium-135 with a half-life of 2.3 million years, and iodine-129 with a half-life of 15.7 million years. Without wasting time and energy on unsafe, earth-built nuclear power plants, we should only consider those plants located a safe distance from population centers. I would say 93 million miles is a safe distance. Our Sun is an ideal nuclear power plant that contains more than 99% of the mass of our solar system. A single sunspot has a diameter larger than our planet, and our giant sun will supply all our energy needs for the next 4 billion years. So, let's make good use of its free energy while we have it. We do have clean energy alternatives. The oil dinosaurs are dying, and we should let them fall. Just don't let them fall on you, the way Enron fell on so many people. Augusten Micheaux, a 19th century French inventor, believed that coal was in limited supply, so in 1878 he demonstrated his parabolic dish concentrator to generate steam and replace coal. Some commercial power plants still use Micheaux's concept of concentrating sunlight, but they use movable mirrors to focus that sunlight on a target that heats salts. The molten salt is then used to superheat steam. Small-scale standalone PV power stations are also possible. They may be connected directly to the grid to generate income. This one combines the advantages of photovoltaics with wind power. Germany is now a leader in the photovoltaic industry. 75% of the electrical energy produced in Germany comes from sun power and wind power. The United States is far behind and produces only 1% of its power from sunlight. Hopefully, the United States will soon catch up as the price of photovoltaics continues to plummet. In 1977, photovoltaic panels were going for $75 a watt. Today they are selling for 75 cents per watt. Roofs provide excellent mounting surfaces for solar applications if they are oriented in the right direction. Besides shedding water, they may be used to gather solar heat or generate electrical power. A well-planned solar home might look something like this. We may have been spoiled by the convenience of energy concentrates such as oil, and we may have concerns about the intermittent nature of sunlight. But this intermittent problem is easily resolved with the use of simple differential controllers for collecting heat and charge controllers for charging batteries. A grid connection for PV systems is another option.